Okay, in our previous lesson, we talked about neutralization reactions between acids and bases. And this lesson, we're going to follow that up with talking and focusing in on titration calculations. So titration is an experimental controlled process of an acid-base neutralization. We use it to determine the unknown, usually concentration of an acid or a base. So if we were back in school, we would be figuring out the percent of acetic acid in a solution of vinegar. And we would do that by using a specific concentration of our base. So we're going to go through the calculations related to this. One important part to know is the reason why we can do these calculations is that in our neutralization reactions, when we get to that part where it's completely neutralized, there must be an equal ratio of moles of H plus ions to moles of hydroxide ions. This is referred to as the equivalence point. That would mean that your titration is complete. You'll also sometimes hear and you'll see in the gizmo the end point. This is where when we do a titration procedure in the lab, we usually use an indicator to show when we've made it to what's called the endpoint, which is hopefully very close to our equivalence point. So in our lab, we usually use phenolphthalein. You'll see a couple in the gizmo. So equivalence point and endpoint aren't the same thing. Equivalence point, again, has to do with the moles of H plus equaling the moles of hydroxide. The endpoint is where the color change occurs, and that's where it signals to you that you're at your end of your titration. So this relationship of H plus ions and hydroxide ions leads to the titration formula. So this top one is right in your reference tables. The molarity of your H plus or your acid times the volume of your acid is equal to the molarity of your base times the volume of your base. One thing though you do have to be on the lookout for is we have to take into account how many H pluses you have in your acid and how many hydroxides. So get in the habit of always writing this kind of second formula down and adding in the H plus on the acid side and the number of hydroxide ions on the base side. So like I said, we have to take into account how many of the H plus and hydroxide ions the acid or the base release. So in this first example, you will see we have a 1 molar hydrochloric acid solution. So in hydrochloric acid, there's only one hydrogen ion. So we would just multiply its side by 1. Same thing if I have 1 molar sodium hydroxide, there's just one hydroxide ion there. Okay, but what about if we have something like H3PO4? Here I have 3 hydrogens that I would have to take into account. Now, if we were in honors or definitely AP, we would handle this acid much differently than using this formula. But just to kind of get the point across in Regents, we have to look at how many hydrogens it could potentially release in solution. Strontium hydroxide, though, is a strong base, and this would release 2 hydroxide ions based on its formula. Okay, so just be checking the formula. I'll show you one example coming up. All right, so let me just show you 2 of these calculations, and then you're going to go ahead and practice it and then do a little review for me. So what is the concentration of a solution of HI? That is 0.3 liters. So that would be HI is my acid. So this would be the volume of my acid. It gets neutralized by 0.75 liters of a 0.2 molar potassium hydroxide solution. So that is my base. So this would be my volume of my base and the molarity of my base. So I'm going to set up my formula. And really, you could put the base on the left-hand side if you wanted to, but just to keep it consistent, I usually just try and keep the acid all on the left and the base all on the right. So I'm just setting this up for you. Okay, and then just a matter of plugging this stuff in. So for our acid, if we look at the formula, we just have 1 hydrogen. Okay, we don't know the molarity, so I'm going to put Ma, but you can just put X there. And then we have the volume, which is 0.3. If I go ahead with the base, I have 1 hydroxide in potassium hydroxide based on the formula. The molarity was 0.2, and then its volume was 0.75. And again, as long as all the information of the acid ends up on the same side together and all the information about the base ends up on the same side, you should be good. So then when you go ahead and do this, just be really careful. It's usually the math step that a lot of you guys have trouble with. If I do 0.2 times 0.75, you get 0.15. Then you have to make sure that you divide by the 0.3, and then that will lead you to your final answer of 0.5. And that would be in your molarity. Okay. All right, in this next one, how many milliliters of a 0.36 molar H2SO4 So this is my acid. We have to be careful because I can see right now that there's 2 hydrogens there, and that's a strong acid. And then this would be then my molarity of my acid. Is required to neutralize 25 milliliters of a 0.1 molar lithium hydroxide solution. So this lithium hydroxide is my base. So this is going to be my volume of my base, and 0.1 molar would be the molarity of my base. So using the same formula as before, I'm going to start with putting all the information about my acid in. So I have 2 hydrogens here, so I have to make sure I multiply that side by 2. I know the molarity is 0.36. I don't know my volume, so I'm going to put VA. You can put in X. Hydroxide here is going to be 1. I have 1 hydroxide in that formula. Its molarity is 0.1. And then we can just use the 25 milliliters as it is. Just realize that that 25 milliliters is what unit my volume is going to be when I solve this. So in this part, if you do 2 times 0.36, you're going to get 0.72 times X or times VA. And then 0.1 times 25 gives you 2.5. Make sure you divide by the 0.72 correctly, so that way you're not getting that point for your final answer. So 2.5 divided by 0.72 gives you like 3.4722. So I'm just going to round this to the tenths place. So I would have 3.5, and then my unit has to be in milliliters there. Okay, so it's just a matter of using and identifying the information in the problem and then applying it correctly into your formula. All right, go ahead and do some practice and let me know if you have any questions.